All right, let's do the 4 lower layers. Now we have the transport, network, data link, and physical. So what happens at the transport layer? The transport layer, now it takes that chunk of data and starts segmenting it. Now it starts breaking it apart. Now it starts putting certain protocols. TCP, connection oriented. UDP, connectionless. Remember I told you in the previous lesson that DNS will use both? Well, it all depends. It all depends on what it's doing. Now, the transport layer makes sure, because if you're using TCP, since TCP is working there, it has acknowledgments, negative acknowledgments, windowing, sequencing. What does that mean? That means it makes sure that when it's going to talk to another computer, that say, hey, listen, let's do this 3-way handshake. Let's synchronize. Hey, are you ready to talk? Hey, I'm acknowledging you. I'm ready to talk. Okay, I acknowledge that you're ready to talk. Let's go ahead and start sending data. That's how that works. TCP. That's why we use TCP/IP. That's the internet protocol. Imagine if that protocol, the suite of protocol, the TCP/IP, even though they're in 2 separate layers, instead of using TCP, we'll use UDP. Sometimes we may get to a web page. Sometimes we wouldn't, because UDP does not do any acknowledgments or windowing or sequencing or anything like that. That's why we use TCP, because TCP is connection oriented. All right, so that's what happens at the transport layer, and we do get these acknowledgments. It makes sure if it gets a negative acknowledgement, because when it comes to the windowing and the flow control, when it sends, you have a window size of 1 or window size of 3, your book explains that. It says, hey, I'm sending you 1, 2, and 3. Hey, I got 1, 2, and 3, send me 4, 5, and 6, and so forth. Or send me 4, and I'll send you 4, 5, and 6, depending on the size of the window. But if you say, hey, I'm sending you 1, 2, and 3, and all of a sudden you reply, hey, I got 1 and 3, I didn't get 2, that means you're going to get resent number 2 before anything else. So it will resend the information. That's the flow control that it has. It makes sure that everything, not only do you get all the bytes that are supposed to be getting to you, but they are in the correct order. They're in the correct order. So your message is not corrupted. And this is where all you see all the different types of attacks, the syntax and all these different things that people attack, that they attack the TCP protocol. So that's your transport layer. The network layer, my favorite layer. There we deal with packets now. Packets. We deal with IP, connectionless. Even though TCP/IP, IP is connectionless. TCP, make sure it gets there. IP is just a driver, right? IPX, we rarely see it anymore. That is NetWare operating system. Hardly see NetWare around much places. We got our routing protocols such as RIP, EIGRP, and OSPF, right? Depending on what type of routing protocol, depending on the types of hop counts, metrics, or cost. Then we have, and that is also considered the logical topology. And obviously we have routers that are working at that layer. So they were testing you, and they asked you a question about OSI. It could be something similar to this. At what layer do routers work at? Let's just say to say a question. Layer 3, network layer. Things like that. IP addressing. That's when we talk about IP. Not only IP version 4, but IP version 6 also works at the network layer. Anything that deals with routing will be at the network layer that deals with the packets. Then we get to the data link layer. Now, the data link layer, you need to understand that is subdivided into 2 layers. You have your logical link control, and you have your media access control. The data link layer is called the go-between layer, the go-between the network layer and the physical layer, because the logical link control knows how to talk to the upper layer network protocols, and the media access control will know how to go down to the physical layer into the 0s and 1s. So it's the go-between, but in today's technology, depending on the application, it may just skip that layer altogether. All right, but in data link, what do we need to know? Frames. Frames. That's what it deals with. Not packets, but frames. What is it? What type of addressing are we looking at? We're looking at MAC addresses, physical addresses, burned in addresses. That's the kind of table it creates. It creates a MAC address table. These switches, bridges, WAN protocols, WAN, PPP, frame relay, X25, MPLS. All those are WAN protocols that work at layer 2. And that's all we need to know. That's all we need to know. I get excited about it, but it's just the fact that, hey, we don't need to get too crazy with the OSI, and that's why these are very quick lessons. Because all I want you to concentrate on is like, hey, I got 7 layers. These are the things that work on those layers, and these are my PDUs. Okay? These are my PDUs. All right. And then the last layer, we have the physical layer, which we have bits. We have bits. What do we deal with there? The voltage, the cabling, hubs, amplifiers, repeaters. Again, WAN, wireless, physical. Very unintelligent devices when we deal with it. You see, that's why the hub is there. All right, so anything that's physical that deals with voltage, you can touch, that is your physical layer. Once it comes out through there, then it goes to the other side with everything in this little sequence, and then it goes up to the other computer, and then things get put back together. So those are your 4 lower layers. A lot of things that are happening here, but again, what do you need to remember? You need to remember the transport network data link physical. The data link is subdivided into 2 layers, LLC and MAC, and that we have the PDUs that are segments, packets, frames, and bits. Okay? Don't forget that. I'll see you in the next one.